Chapter 11, Manufacturing, Processing, and Product Lifestyle, Part 2 of 4. Permanent mold casting. Permanent mold casting is very similar to both die casting and sand casting. This process uses permanent die halves similar to those used in die casting machines. The molten metal is poured into the top of the mold, similar to the ways a sand casting is done. Permanent mold steps. Step 1. The mold is prepped by preheating it to between 300 degrees Fahrenheit and 500 degrees Fahrenheit to allow metal to flow through the mold easier. A ceramic coating is evenly applied to all surfaces of the mold, making it easier to remove the parts as well as extending the life of the mold. Step 2. If the mold has internal features, a core may be used. Sometimes these cores are made of steel and sometimes sand. The two halves of the mold are clamped together, and the molten metal is poured through the sprue in the top of the mold. In step 4, after that part has had time to cool and solidify, it is removed from the mold. Any excess metal from the sprue and runners is sucked away to produce a finished product. Metal forming. Forming encompasses many different manufacturing processes in which a material is permanently deformed. Forming metals involves permanently changing the shape of the material by applying pressure. Hot forming metal. Hot forming metal is always done above the metal's recrystallization temperature so that the metal's strength decreases and is more easily formed. Metal forging. Today, forging is widely used to make tools, aircraft components, and other parts where strength is a concern. Forging is a form of metal forming that involves shaping a metal part through controlled plastic deformation. Most forging operations are done in a multi-step process that allows the material to be gradually worked into the final shape. Open die forging. Open die forging involves squeezing or impacting the metal between flat or round dies until it takes on the desired shape. The open die forging process is usually reserved for low production runs or custom forgings. It is commonly used as a primary processing technique to prepare the material for secondary processing. Upset forging. Upset forging involves compressing metal along its axis to decrease its length and increase its cross-section. Closed die forging. Forging dies are shaping devices with impressions, or cavities, machined in both halves of the die. The impressions shape the material during the forging process. Hot roll forging. Hot roll forging involves placing either round or flat stock between roller dies that reduce or change the cross-section and increase the length of the material. Metal extrusion. Metal extrusion is a manufacturing process used to create parts with uniform cross-sections. There are two ways to perform metal extrusion: direct extrusion and indirect extrusion. In direct extrusion, the extruded product moves in the same direction as the ram. In indirect extrusion, the die moves towards the billet, which remains stationary. Extrusion can be done either hot or cold depending on the shape and material being processed. Cold forming metals. Cold forming metals is always done when the metal is at room temperature or slightly warmed. The process of working a material that has been warmed is called warm forging. A computer numerically controlled or CNC tube bender, which can be programmed to produce custom bends and long metal pipes. When metal is forced through or around a die by stretching, compressing, or bending, the process is called drawing. Drawing is a form of cold forming techniques used to produce a wide variety of products. Processing plastics. There are two major classifications of plastics: thermoplastics and thermosets. Thermoplastic is a type of plastic that has the ability to soften when heated and harden when cooled. Thermoset plastics have undergone a chemical reaction when exposed to heat that caused the polymer to harden. Processing plastics. Plastics can be formed using a number of different methods, including blow molding, thermoforming, extrusion, injection molding, and metal injection molding. Blow molding. Blow molding is a process used to create hollow plastic parts. Thermoplastic pellets are dumped into a hopper and fed into an extruder where they are melted. The molten plastic is forced into the die head and squeezes out between the blow pin and the die to form a hollow plastic tube. This tube is called a parison. High pressure air is injected into the parison through the blow pin, forcing the molten plastic against the walls of the mold cavity. Thermoforming. Thermoforming is ideal for shaping flat sheets of plastic into finished parts. The plastic is heated until it's easily malleable, and then the vacuum is turned on to draw the plastic toward the bottom of the mold. Pressure forming is a thermoforming technique that is identical to vacuum forming, except compressed air is blown in above the part. Steps of the extrusion process. Step 1. Plastic material is mixed with additives and coloring agents to alter the properties of the final product. Step 2. The material is heated to achieve a uniform viscous consistency. Step 3. The molten plastic is forced through a die to form the desired shape. And Step 4. The plastic extrusion is allowed to cool. Injection molding process steps. Step 1. Plastic pellets are poured into the hopper. Step 2. The pellets fall through the open bottom of the hopper and into a barrel. Step 3. The barrel contains heaters that melt the plastic to a uniform consistency. Step 4. A reciprocating screw is used to move the molten plastic toward the mold. Step 5. The mold is closed. And Step 6. The entire screw moves in a linear motion toward the mold, forcing a shot of plastic through the nozzle and into the mold. Injection molding process steps. Step 7. The plastic is quickly forced into the mold cavities. Step 8. The plastic is allowed to cool. And Step 9. The molded parts are ejected and the process starts over again. That ends part 2.